All right, hey guys, we're gonna finish it up. Sorry I couldn't get it into one video. So we want to go into length of an arc. So how long is it around this circle, right? How long is this piece? You do have a formula, so arc length equals r is your radius, and theta, be careful because it's the measure of the angle in radians, So when we look in this problem, we do have a radius, right, 6 inches, but we have our degree, our measure of our central angle is in degrees. So we do need to convert that, right, times pi over 180. We need to convert that before we can do our formula. So divisible by 45, divisible by 45, and you get pi over 4 radians. Now you can plug in arc length is your radius times your radians, So radius was 6, I'm going to write that as a fraction, and our central angle was pi over 4 radians. Let's simplify, divide by 2, and we get 3 pi over 2 inches. Or it also says round to 2 decimal places. So if you type that in your calculator, 3, hit that pi button, 3 times pi, and then divide by 2, you should get 4.71 inches. All right, so that's your two different in terms of pi and rounded. Next one. We're also going to talk about linear and angular speed. So if you're wondering what the difference between linear and angular speed is, if you look here, linear speed is the arc length, how much you traveled, divided by the time it took you. So we're used, this is miles per hour type of stuff. So the distance you traveled versus how long it took you. Angular speed is more about the revolutions because you're talking about the radians you covered, right? The radians you covered over the time it took you. You can toggle back and forth between linear and angular speed with this formula. So this formula says to get linear speed using angular. To get linear using angular, you have to take angular and multiply it by the distance from the center of rotation. So in this one, it's talking about iPods, and it says before iPods were a thing, we actually had records. So they had something called a 45 revolution per minute record. And that's what that stood for, RPM, revolutions per minute. And that's what the angular speed is here, 45 revolutions per minute. They want us to convert it to linear speed. So we have our formula, right? V equals R. Okay. So the first thing is we need to get in terms of radians per minute, So let's get revolutions into radians. So if you have 45 revolutions per minute, we know that there's 2 pi radians in 1 revolution, right around. 1 revolution around is 2 pi radians. So here we'll get 90 pi radians per minute. All right, so there's my angular speed, 90 pi radians per minute. And we're going to take that, and I tell us that it's 1.5 inches from the record center. So there's our R, rotation from the center. So we have 1.5 times our angular speed, which we just found was 90 pi, radians per minute. And we're going to go ahead and multiply those. And we get 135 pi inches per minute. And then if you wanted to do rounded to whatever, because they didn't really tell us, it just says find the speed. So if it was in terms of pi, we would stop there. If it wasn't, we could do 135 times pi in our calculator, and we would get about 424 inches per minute, which makes a little bit more sense. All right. That's it. Bye guys, finish your homework.